Please check your notes. Any doubt from yesterday's class? We were discussing Earth's interior. In yesterday's class, we have completed one topic, that is Earth interior. And in this, we were discussing evidences of Earth interior. Evidences of Earth's interior. Okay. So already you know various layers, multiple layers within the Earth, you know. How they were formed, you know. Correct formation. What are the different layers, discontinuities, you know. And in the evidences of Earth interior, we were discussing direct evidence, indirect evidence. Indirect evidence. In direct evidence, we have discussed 5 points: minerals, rocks, mining, correct, drilling, super deep drilling, integrated drilling, correct, deep sea mining, and also volcanoes. Those are all comes under direct. So in exam, you should know this flow chart, because before you frame the answer, the overall what should come what, when, that you should know. The flow of answer is very important. The flow of answer. So if they ask you Earth's interior and direct evidence, then you write this and this much. Okay, like already we have discussed rocks and minerals. Okay, so then we have mining activities across the world. That also is one direct information. So we have discussed drilling, super deep boreholes. Okay, then deep sea mining and volcanoes. So they'll ask, discuss Earth's interior with a suitable diagram and elaborate the direct sources of evidence of Earth interior. What are they asking? They are asking this. They are asking direct sources of evidence. They are asking. So you should write this. Okay. If they ask you indirect evidences or indirect sources include first one, let's earthquakes. Indirectly, we can ascertain what is happening through seismic waves. That is one. B. Asteroid impacts also shed light about Earth interior. I'll tell you how. Gravity variation. Yes, magnetic field. Like this, these are indirect. These are indirect sources of evidence. So please remember indirect. Okay. Any doubt in these? Okay, we have covered all these aspects now. So let's start with the indirect sources of evidence. In direct, what happens? A scientist will directly observe a phenomena, directly collect sample, observe, study, and then conclude. This is direct, where the scientist is directly involved in the exploration. Indirect is through indirect methods, because earthquake waves, seismic waves go deep into the earth, right? Can the scientist also go? No. Only we can place some seismograph all around the earth. Using the seismograph data, we can know what is happening inside. Let's say sometimes we get a ECG done. Correct. It is a non-invasive study. What is non-invasive means, like above the art only they will place some sensors. Using that sensors, they will detect your correct. So variation in the heart rate and all they will check. That is non-invasive study. So internally we'll come to know what is there, what is the problem. If there is any problem and all, we'll come to know. Correct. Based on that, the doctor can suggest. That's like that. That is indirect. Indirect way of knowing what is happening inside. I just gave you an example of ECG, so you'll all understand. Okay. So seismic waves are like that. Because when the earthquakes occur, water bottle. So when the earthquakes occur, I'll show you how it happens. Let's say this is the Earth's surface. Okay. So there are, let's say, a fracture or a fault. A fracture here, or a fault. In this kind of fractures and faults only earthquakes occur. So this place where the earthquake occurs is called as focus. Focus is the point of origin of an earthquake. Okay, this is where the earthquake occurs. So when the earthquake occurs, large amount of energy is released. Just like when you throw a stone into the water, as soon as you drop, what happens? There is ripples in the water. Have you noticed that? We all like to do that. Every time there is water, you throw a stone and see what happens. As soon as it falls, you can see energy transferred from rock to the water and ripples of energy going in all direction. So correct. Just like that, the seismic energy will go in all direction now, like this, carrying the seismic energy in all direction like this. These are called as seismic waves. Seismic waves. Waves are nothing but energy in motion. Seismic waves are energy in motion. So they go in all direction like this. The first point they reach is this, exactly above the focus. Exactly above the focus. This point is called as epicenter. Epicenter, correct? I'm not starting the earthquake topic. I'm just telling you what happens inside. That is a separate class, 2 hours class. Earthquake itself is 2 hours class. We'll discuss that separately. For now, I'm just telling you how the seismic waves pass through. The study of these seismic waves is called as seismology. Seismology. Okay. A scientist who study earthquakes are called as seismologists. So what seismologists do? They'll help us to know more about the earth interior. Okay. So what we'll do, we are placing a seismograph. Let's say I'll show you here. Let's say this is the earth's surface. We dig deep into the earth's surface. There is a bedrock, hard rock. Within the rock, we are placing a seismograph here. Seismograph here. A seismograph is a kind of an instrument like this, a box, like simple instrument. Seismograph looks like this. It'll have a pendulum, kind of a rope, and a weight, a small weight attached to it, and a pen, microtip pen. You can understand a pen? Microtip pen. Okay. Below is the rotating drum like this. So this is a pen, this is the weight, this is a thread, like a pendulum. Okay. So this is here inside. Like this. Like this. Okay, it looks like this. When the seismic waves reach all direction like this, what happens? The rocks will vibrate like this. This box also will vibrate. What happens to the pendulum? Will move. Pendulum will move. This pendulum will move. When the pendulum moves, what happens? It will mark on the paper. This is a pen, Allah. The pen will mark on the graph sheet like this. Otherwise, normally, if there is no earthquake, manlo, there is no earthquake means there will be a straight line like this on the graph sheet. Earthquake hone ke baad, it will record like this. It like this. This is recorded. What is recorded? Seismic waves are recorded by this. Just like our ECG recorded. So this is a recording of the ECG. Just like our electrocardiograph. Just like that, seismograph. Seismograph records our seismic waves. So written. It's a recording instrument. So what is recorded now? The earth's vibration is recorded. These are called as seismic waves are recorded here. This is the printout. This is a printout. We can cut that paper and remove it. So then we come to know. So seismic waves are of two types: body waves, surface waves. Like this. Okay. Body waves and surface waves. Body waves may again primary, secondary. Surface waves may Rayleigh, low. Like this, we have multiple waves. So the scientists will come to know. We are not going inside. I'm not going inside. I'm just noting down the vibration on the surface. Who? Seismologist. Okay. By doing this, don't you think we'll come to know what is happening inside? How much energy is released? Correct. What is happening inside and how much energy is released? How much damage it can do? Damage also. We can come to know. So this is indirect. Indirect way of knowing what is happening inside. Okay. Just remember the example I gave you, like a cardiologist taking the ECG. Okay. It's a non-invasive study. Above the surface only, they are getting the information. Just like that. Okay. So simple example I have given you. So please write. Earthquakes shed light. Shed light on about various layers. Earthquakes shed light, shed light on various layers of the earth interior. various layers of the earth interior. Okay, they shed light on various layers. Which are the different layers? Yesterday, remember I told you we have so many layers: continental crust, oceanic crust, upper mantle, lower mantle, outer core, inner core, like that, various layers of the earth interior. So with the help of these waves only, we came to know that outer core is liquid, inner core is solid. Okay, please write. With the help of body waves, we came to know about the earth's interior. With the help of body waves, we came to know about the earth's interior. Earth's interior. For now, this much is enough. When I do earthquake class, I'll tell you more information. For now, what happens if I tell also that S waves are secondary waves, shear waves, they can only pass through solid, they can't pass through liquid, you'll not understand now. We need more basics to reach there. For now, you remember, body waves helped us to know that earth interior, about the earth interior. For now, enough. Write this diagram quickly. This is how the seismograph look like. This is a seismograph here placed. The bigger version I'm showing you for your understanding, because this is very small diagram. So what seismograph do? They record seismic waves. So the seismic waves helps us to understand what is happening inside the earth. Focus is a place of origin, or the point of origin of an earthquake. Point of origin where the energy is released. Epicenter is a point where, just above the focus, where the energy reaches first. Energy reaches here also, but first it reaches epicenter, just above the focus. That is a fault. F-A-U-L-T, fault. Most of the earthquakes occur along the fault. Okay. Body waves, surface waves. P is primary. S is secondary. R is Rayleigh. L is Love. Okay. Name of the scientist. These two are name of the scientist. R is Lord Rayleigh, scientist. L is also name of a scientist. A-E-H, Love. His name is scientist name. Okay, Love. Because in earthquake class, we can extend this topic for another 1 hour, 2 hour, we can explain this. Here we are writing an answer for this now. Here I have to cover equally. This also I have to cover one small paragraph. This also I have to cover. This also I have to cover. This also I have to cover. In exam, what students do is, earthquake they start and they write 2 pages on that. On this they will not write anything. One line. Then you will not get marks. So you have to equally divide the answer. Give equal weightage to each point. Let's say, Manlo, I will do 5 pages on this now. So you also will do the same in the exam. While writing, you will write more about this. So I am limiting myself here, because yesterday, remember, for each of them we gave some information. That much is enough. Here also we have to give information for each one of them. So then answer also will be balanced. When we do earthquake class, we can go on for separate 2 hours class. Now I am just telling you the basics. This is called as an introduction to earthquake. That's it. Correct. A simple introduction to earthquake. What is it? Focus, epicenter, you know. What is seismology, you know. Study of earthquake. What is seismic waves, you know. That much is enough. The energy passing through the rocks are called as seismic waves. Okay. The waves that travel through the rocks are seismic waves. Can I continue? So the first topic, all of you know, indirect way of ascertaining about the earth interior. So this will help us to know what is happening within the earth. Okay. So next, asteroids. Asteroids are remnants of planets. Remnants of planets. Means our planets, we have Mercury, Venus, Earth, Mars. These are rocky planets. After the formation of these planets, inner planet, the remaining rocks are called as asteroids. Asteroids are large boulders of rock with more than 1 meter diameter. Asteroids are large boulders with more than 1 meter diameter. So any rock in space which is more than 1 meter in diameter are called as asteroids. So they are mostly found between Mars and Jupiter in an asteroid belt, correct? They are found in a asteroid belt between Mars and Jupiter. Okay, they are remaining portion of the planets. So remnants, they are more than 1 meter diameter. They are located between Mars and Jupiter. There are nearly 1.1 million asteroids in the asteroid belt. In the asteroid belt, there are nearly 1.1 million, means nearly 11 lakh. 11 lakh rocks we have counted now. NASA has counted nearly 11 lakh or more than that. That many rocks are there in between Mars and Jupiter. Let's say this is Earth, this is Mars, this is asteroid belt, and this is Jupiter. Correct? So this is Mars and this is Earth. Asteroids are here between Mars and Jupiter. So all of you know the location. So there are so many here. Here. Like this. Occasionally, these asteroids collide with each other. When they collide, some of them will be pushed out of their orbit. Their normal orbit is between Mars and Jupiter. They are also orbiting Sun. Okay. When sometimes they collide. When they collide, they come out. So the asteroids, when they come out, so they will be roaming in space. So suddenly what happens? The Earth's gravity will pull them. Among the inner planets, the biggest is Earth. Correct? Earth is the 5th largest, but among the inner planets, we are the largest. So the asteroids get pulled in towards the Earth because of the Earth's gravitational pull. So these asteroids now move towards Earth in a hypervelocity. Hypervelocity means very high velocity. They'll not come slowly, they'll come at a very high speed. So Earth's gravity is also attracting them. So when they come closer, what happens? We have atmosphere. That is our first line of defense. So the asteroids enter our atmosphere. If they are very small, they'll burn up. In the space only they'll burn, because at a high speed they are entering, friction is there, oxygen is there in our atmosphere, so they'll burn. What if there are large, big size asteroids? They end up on Earth. If this is the Earth, the asteroid comes and falls on Earth like this. Correct? When the asteroid falls, there will be a huge mega earthquake on the Earth, and the asteroid rock will get embedded into the ground. The piece of rock gets embedded into the ground like this. A crater is formed. One second, I'll show you. A huge crater, you can notice. A U-shaped crater is formed on the Earth, and the rock gets embedded into the ground like this. It gets embedded into the ground like this. Means it gets buried because it is falling at a very high speed. So after the asteroid impact, if we go here, we can extract that rock piece out. That asteroid, we have taken it out in many places, and we can drill into an asteroid. When we drill into an asteroid, we have come to know the center of the asteroid contains nickel and iron. The asteroid core contains nickel and iron. Okay, and surrounding minerals are iridium mainly, which is very rare on Earth, which is found only in the asteroids. So if we go and inspect this crater, this is called as impact crater. Impact crater is a crater formed due to an asteroid impact. Impact crater is a crater formed due to a asteroid impact, like a U-shaped crater. So there we get the rock. When you notice there, that area, surrounding area, we'll get a mineral called iridium, which is very rare on Earth. Only in these spots we'll get it. In that surrounding area we get that iridium mineral. So whenever we get this iridium mineral, that indicates that some asteroid has fallen in the past. Correct? So those areas we inspect, there will be some depression. That depression is now will be under water. Lake ho jayega ba. Lake. So if we go and inspect there, asteroid rocks will get. You have to take it out and drill. When you drill into it, we have come to know that it has iron nickel core. That means asteroids are what? Remnants of planets. They are called as minor planets. If you ask me, asteroids are called as minor planets actually. So by understanding the inner areas of the asteroid, we'll come to know, okay, Earth also will be same. So by understanding an asteroid, we have realized that all Mercury, Venus, Earth, Mars, all the inner planets have iron and nickel core. The core of the inner planets are made up of nickel and iron. So we have realized that Earth is also same because it is denser. I told you, denser minerals will go inside. Similar here also. So iron nickel contains nickel and iron. So please remember this. So please write this now. Asteroid impact. I'll show you a few places like India mein Lake Lonar. Lake Lonar in Maharashtra. Okay. Like this we have so many other places like Chicxulub crater. Mexico. All these places where we can see asteroids colliding. Impact crater. So this is asteroid. I'll change the color of the asteroid. This is a crater. Notice this crater has lake now. Impact crater is the crater formed due to an asteroid impact. So inside the asteroid, it contains a lot of iron and nickel. So we realize, okay, all the inner planets might be same. Okay. So asteroids also help us to understand our Earth interior indirectly, but you might say, sir, this is not a direct information. Yes, that is the reason we have classified it as indirect. Because indirectly we are imagining, okay, Earth also is same. Okay. Clear till now? Okay. So we have covered the main aspect here. I'll show you this one. Crater lake I'll show you. I'll show you Chicxulub first. See, this is an asteroid. Okay. So this fell somewhere in North America. Chicxulub crater. It lives behind this kind of depression, crater. Okay. Here. So all of you know this is USA, Mexico. This is Gulf of Mexico. Today it's called as Gulf of America. So this is Chicxulub crater here. The asteroid fell here in this part 65 million years ago. So this is one of the reasons for the extinction of dinosaurs. 65 million years ago, not now, 65. Okay. It fell here, that led to a huge depression here. Asteroid impact. The initial crater starts here and goes like this. Okay, below here we'll get a lot of asteroid rocks. So this is one of the major evidences for us. Asteroid rocks and all we have collected here. This is Lake Lonar. Lake Lonar, Maharashtra. See how it looks, a huge crater lake. Depression form होगा, उसके बाद rain water will collect, forming this kind of lake. Okay, certain bacteria in it, they'll turn the water pink like this. The bacterial growth in this water causes the lake to turn into different colors. Okay, Lake Lonar. Okay, please remember. It's the impact crater. So now all of you know how it looks. See, we got so many rock samples like this. Asteroid rock samples in different parts of the world. Using this rock sample, we'll come to know the mineral composition and all. Okay. Okay, so this is again indirect evidence. Next, right, gravity. Gravity. Okay, so now we have to understand the shape of the earth first. Earlier, remember, I was talking about the shape of the earth in the previous class. The earth's shape is geoid, I told you. Because of the fast momentum, earth was rotating at a very high speed. So what happened? Earth bulged because of the fast momentum. So the equatorial areas here bulged outwards here because of very high fast rotation. Remember, I was telling you in the initial classes, when the earth formed initially, earth was spinning at a very high speed. Our momentum was very, very high. First classes I have told you, both NCERT and UPSC class. When earth spins at a very high speed, what happens? The centrifugal force will be very high here. These areas. Centrifugal is outgoing force. And earth was spinning once in 4 hours, just 4 hours. Initially. At a high speed, such a high speed, what happens? These areas will bulge outwards. Here, these areas near equator, it will bulge outwards. What about the polar areas? Here centrifugal force will be minimum, so it will bulge in. Okay, as a result, equatorial areas will bulge outwards. The polar regions here, north pole, south pole, will be bulging inwards because of the very high centrifugal force. Because of the fast rotation, the equatorial areas bulged outwards. Okay, so that is the reason our earth shape is like this. Okay, this shape of the earth is called as geoid shape or oblate spheroid. Technically called as oblate spheroid ellipsoid anta. You remember this word oblate. Oblate means obese. When we become fat, what happens? Stomach comes out just like that. Oblate means what? Obese. Earth is obese like this. So that means what? From the center, notice this please, all of you. From center to equator, the distance will tend to be higher. Correct. From the center to equator, the distance, let's take A. From the center to the north pole, south pole, let's call it as B. Don't you think from the center of the earth to the equator is slightly more than from center to the poles? Because it is bulge at the center, from the center to the equator, distance appears to be slightly more than towards north pole or south pole. When the distance is more here, what happens? The gravity tends to be less near equator. That is the reason gravity is less where? Equator ke paas. Gravitational pull is less near equator. As we go towards polar region, since the distance is less, the gravity increases. Okay, so all of you know gravity is directly proportional to product of the masses, indirectly proportional to the squares of the distance. Okay, gravitational force. So if you introduce the constant like this, so gravitational force is inversely proportional to the distance. Correct. You can notice this. Here the distance is high, so gravity will be low. Here the distance is less, gravity will be higher in the polar region. So the polar region tends to have higher gravity. Okay, so that is the reason we always launch the rockets closer to the equatorial location. Correct. All the rockets are being launched from the equatorial location. Polar regions may gravity tends to be higher, so it's slightly difficult. I'm not saying not possible, slightly difficult. But Russia does it. Russia has a very powerful rockets, powerful engines. They launch from the equatorial. They launch from polar locations. They can launch it from anywhere. Okay, strong rockets. They can easily pull up against the gravity. Otherwise, not possible. Recently, I think a week or two back, UK was launching a rocket. Here, UK, temperate country. So it went up and then fell back. They were launching it from UK itself, Great Britain, directly. They failed. Okay. So as a result, you should know equatorial areas tend to have lower gravity. So the gravity of the earth varies from equator to the poles because of the shape of the earth. Because earth shape is geoid shape. So from equator to the poles, the gravity will vary from here to here. Okay, gravity of the earth will vary according to because of the shape of the earth. That is one. Because of the earth shape, geoidal shape. One. Gravity of the earth will vary also according to the mass of material, distribution of mass of material. Mass of material, because earth earth में matter is not uniformly distributed. Certain areas we have certain types of minerals in large quantity, in certain areas we have less. So distribution of matter is not uniform across the earth's surface. Do we get iron everywhere? Do we get gold everywhere? No, because there is no uniform distribution of resources. So certain areas there is large scale accumulation of iron. For example, in India only you see large scale iron is found in Karnataka or in Jharkhand, Chhattisgarh, Odisha. These two places only. Rest of the places no. Gold is found only in certain places. Karnataka, Andhra Pradesh. That's it. So like that, there is no uniform distribution of resources. So the gravity of the earth will vary according to the earth's shape. One, okay, because of the bulge shape here, gravity is less. As you go here, it will increase. That is one. Second, the gravity of the earth will vary according to the distribution of mass of material. Distribution of material. You first write this, then I'll explain again. Distribution of material. So gravity of the earth varies based on two aspects. One, the shape. Second, the distribution of matter, because matter is not uniformly distributed. Please write both the points and this diagram. Done? Okay. So the gravity of the earth varies according to the shape. That is one. Second is distribution of mass of material. This variation of gravity from place to place, as we measure gravity, it will vary from place to place. That variation is called as gravity anomaly. Please write gravity anomaly. The variation of gravity across the earth's surface is known as gravity anomaly. Variation of gravity across the earth's surface. Okay. When I say variation, I'll explain now. How does scientists measure this? There are two things. One, we use an instrument called gravitometer. Okay. So gravimeter we call it as gravimeter or gravitometer. Okay. So what we do is, please notice this. When we measure gravity, we have two types of gravity. One is theoretical gravity. Okay. Theoretical values. Theoretical values of gravity we take first. What should be the gravity here? That is one data. Second, observed value. Observed. We will go there using a gravity meter. We'll measure the observed value. What is the gravity in that place, depending upon the mass of material. The difference between this is called as gravity anomaly. So there are two types of values we get. One is theoretical value of gravity. What should be the gravity here, and theoretical we can calculate. Second is the observed value using the instrument. So the difference between these two gives us the gravity variation. So the variation of gravity is measured by taking the difference between the theoretical values and the observed values. I'll show you now. Theoretical values and observed values. Please write. The variation in gravity is measured by taking the difference between theoretical value and observed value. By taking a difference between theoretical value and observed values. Okay. Can I continue? So this is how okay. So we have spring gravimeter. Here. Spring gravimeter is the one that we use. Other one is free fall gravimeter. This one we use. I'm just telling you types of meters we use. Gravimeter, I told you, instrument. Unit is meter per second square. Unit. Okay. So free fall gravimeter. Superconducting gravimeter is expensive. We don't use. But spring one and that one. These are the ones which we use normally. Okay. For measuring gravity. So this is first one. You have seen how it looks. Okay. So gravimetric. Oh, it's showing the liquids. 1 second. Okay, I'll show you the values itself. Huh. So by taking the variation of the Earth's surface, you notice. So when we say this, the Earth's surface is highly uneven. Okay. So this is, you can see the first is the ellipsoid Earth, the blue circle that you are noticing here. This is the blue color line that has gone here. So that is what we call it as the shape of the Earth in general, or the spherical shape of the Earth. That is considered as the normal. But actual shape of the Earth is like this. Variation, you notice this variation of the Earth surface. Ups and downs it will go. Okay. Next, see the geoid. Geoid is what we imagine Earth to be. Correct? Now, when I show you the actual image of the Earth, you'll be shocked. What we imagine Earth to be and what actually it looks like is different. So the gravimeter will measure the gravity in different spots on the Earth's surface. Correct? That value is there. Plus, what should be the theoretical gravity that we have? Based on the difference, we can tell how the gravity is varying. So the gravity meter or gravimeter helps us to understand how the see, this is how actual Earth looks like. This is how the actual Earth looks like. You can notice this. So it looks kind of weird, right? So this is actual Earth's surface variation. If you take, it looks like this. But the picture what we show outside, it looks different, correct? Blue and white and rock surface and all, that is different. There we show water and clouds in the actual image of the Earth. But real image of the surface of the Earth is like this. It looks like this. So you can notice red color indicates the gravity levels in milligal or meter per second, you can see here. Blue indicates very low gravity. So that means across the Earth's surface, the gravity is not same everywhere. It will vary from place to place. It depends upon the shape. It depends upon the distribution of mass. I think I'll show you a better image. I think this only, if I zoom in, I'll get it. So remember the instrument, gravimeter. So this is how we measure, like for example, the measured value and the observed value. Okay. So you usually take that. I'll show you how it is done. See. So gravity, how it is varying, you can notice. So certain places you can see gravity less, certain places very high, you can see. Okay. Unit is also milligal also we can use. One spot we have noticed is India. Just below India, you can notice this. Okay, Indian Ocean. This region has the lowest gravity in the entire world. This we have come to know now. Indian Ocean geoidal low, we call it as. Indian Ocean geoidal low. Okay, Indian Ocean geoidal low. Please remember IOGL. This is going to come in the exam, I am telling you. I am showing you the image and I am telling you this is going to come. Mark it as very, very important. Okay. So please remember this point. Indian Ocean geoidal low. Here. You can notice in this. Across the Earth's surface, you notice the variation of gravity. But especially Indian Ocean below Sri Lanka, below Kanyakumari, it has the lowest gravity. This place has the lowest gravity on Earth than any other place. So this is called as Indian Ocean geoidal low. So we have observed very large scale gravity anomaly. Okay. And also you notice the equator is passing here. Okay. But this place also equator is there. But here we don't see much difference. But here we see a lot of difference because of the distribution of mass of material. Why is this? Because of difference in the mass of material found. So this is one of the reason why, say, this is one of the reason why ISRO is shifting its rocket launching station from Sriharikota to here, to the Korean ke paas, Kulashekara Pattanam is our new rocket launching station, which is close to the Indian Ocean geodal low. Okay, this is our Sriharikota. Okay, Kulashekara Pattanam is here. Okay, this is yes, Kulashekara Pattanam. Like this, you can understand. So, what is geodal low? You know. Okay, geoid is Earth, low because of low gravity anomaly. What is anomaly means? Difference between theoretical and observed. So, this is very low, even than the theoretical values. As a result, it is called as lowest gravity anomaly on Earth. They'll ask, where is the lowest gravity anomaly observed on Earth? Indian Ocean, below India. Okay, so please remember this. So, I am technically linking the topics. That's it. So gravity anomaly, all of you know, gravity varies according to the shape of the earth, and also it varies according to the distribution of mass. Okay. So you know the unit. We have covered earthquakes, asteroid and gravity. Last one, magnetic field. Magnetic field. Okay. In the first class, I was telling you about the segregation of material. Initially, Earth was in a hot molten state, I told you. Correct? Quickly, we'll revise. Hot molten state. What happens when the Earth is in a hot molten state? I told you there is a chances are very high that material will move. The denser elements, all the heavier, denser elements will collect at the center because of the molten nature of the Earth. Because of the molten nature, the segregation will take place. All the denser elements will come to the center, forming core, which will contain here nickel and iron. So these two are ferromagnetic minerals. These ferromagnetic minerals will accumulate in the center, forming core. So this core, now please notice this. Slowly, all the other remaining minerals will move to the surface here, like this. Low density minerals forming crust. The crust, mantle and core is formed. Once this is formed, what happens now? The center of the earth behaves like a magnet now. Because of the nickel and iron here, the inner core behaves like magnet. Even in yesterday's class, I was telling you, the inner core is solid. Outer core is liquid. So the outer core mein the material is moving like this. The liquid knife in the outer core is moving around the inner core. That magnetizes the inner core. The movement of material in the liquid core magnetizes the inner core. So the inner core behaves like a big magnet inside. Okay. So the currents that are passing through the outer core here magnetizes the inner core. I'll show you this also. We have made an image of this. So you have to remember, the outer core is liquid, inner core is solid. Yesterday I have explained why and the. Okay. So the movement of material in the outer core magnetizes the inner core. Okay, I've repeated it thrice. Please remember this. Like a solenoid. You might have seen a solenoid. It's like a wire, and you have pass another electric coil around it and pass electricity around it. So this center rod gets magnetized. Just like that. Okay. So when the outer core is moving, liquid material is moving around the inner core, this gets kind of magnetized. So the inner core behaves like a big magnet called geomagnet. Geomagnet. So inner core behaves like a magnet. How it is formed, I told you. First, the segregation takes place. All the denser elements come to the center. Based on density, they get separated. This is first step. Later elements go to the surface. Crust is formed. Core is formed. Then the core gets magnetized and behaves like a magnet. Since both iron and nickel are ferromagnetic minerals, iron and nickel both ferromagnetic. So they behave like natural magnet. magnet. Done. So this already we know because day before yesterday also we did this. But now I am telling you why exactly the inner core behaves like magnet. Because yesterday's class we have covered what is outer core and what is inner core. Huh. So now if you take a magnet inside the earth now, like a bar magnet with two polarities. Every magnet will have two polarities, north and south. Opposite polarities attract. Like polarities repel. Huh. This you know. So the magnetic lines of force start from the north of the magnet and converge where? On the south. Like this. This is magnetic lines of force. These magnetic lines of force start from the north and they converge where? On the south. Like this. It starts from the earth interior, goes up to 60,000 kilometers in space. It goes up to 60,000 kilometers in space. Okay. Please remember this. This magnetic field of the earth is called as magnetosphere. Magnetosphere. The region around the magnet where we can feel the attraction or repulsion is called as magnetic field. Okay. That also you know now. All this I am repeating from the first day's class. Okay. Magnetic field, all of you know. What is magnetic field? The region around the magnet where you can feel the attraction or repulsion. That area is called as magnetic field. Also known as magnetosphere. It starts from the earth interior and goes up to 60,000 kilometers in space. So, and I told you in the first class, this magnetosphere protects us from the solar wind and solar flares. Correct? I told you magnetosphere protects earth from the solar flare. The first class is very important because already I have explained this. Clear? So because I have to write here again, in the exam you can't skip this. In exam you can't skip this topic. That also you have to write small paragraph of this. You have to show this. The earth inner core is magnet. Okay, because of this magnet we have magnetic field and it looks like this. It protects us from the solar flares. It goes up to 60,000 kilometers in the space and all you should write in the exam. Okay. Here also I can't skip. Just because I did it in day before yesterday, no I can't say I have done that. That is the reason even I am repeating. Okay. If the teacher becomes lazy, students automatically become lazy. You got it? That's what I have seen. So as a result, I don't want to do that. Okay. And I told you how the compass works. I was teaching you the other day how the compass in your phone, compass if you hold in your hand. Correct. Every time you hold the compass, there is something called needle. Correct. What that needle will be doing? It will be moving like this. And after some time, it will come to rest if you hold it. That needle N, you are keeping it where? On the earth's surface. Here. Correct. Let's say this is needle. You are on the earth's surface. This magnet is where? Inside the earth. I am repeating again, all of you notice. The needle N of your compass will coincide with the earth's south because opposite poles attract. They align. The south of your needle align with the earth's north. You got it? Okay. Pass me your pen 1 second. Pen. So let's say this is the magnet inside the earth. Like this. So this is the magnet outside. Like this. It will align like this. Or like this. You can notice. North, south and north. They'll align like this. This is inside. This is like this. This is fixed. Let's say this compass you are holding. If you hold it like this also, needle will come like this. Okay? So because opposite polarities align. So that is the reason we call this point as magnetic north. This point as magnetic south. Please write. And this line connecting north magnetic pole and south magnetic pole is called as magnetic axis. Magnetic axis. What is magnetic axis? They'll ask. Magnetic axis is the axis connecting north magnetic pole to south magnetic pole. I am writing white color for earth so that some color difference is there. And also I hope I told you why we should not face in the direction northward direction. Also I was telling you the other day, so you should always face south when you sleep. Okay. What is magnetic axis? Magnetic axis is the axis connecting north magnetic pole to south magnetic pole. Okay, can I go to the next slide? Done till now? Too technical, I agree, we can't do anything. Okay. And also we can write magnetic field is measured using magnetometer. Please write magnetometer. Unit Tesla or Gauss. Gauss or Tesla unit. Gravitometer is gravimeter, gravity, either milligal or Newton or meter per second square. That is gravity. Magnetic field is measured using magnetometer. Unit is either Tesla or Gauss. Scientist names. Okay. So all of you know about the magnetic axis. Now many of you will be wondering, so what about the Earth's axis? Earth axis will be this. This is the Earth's axis, the axis of rotation. Earth's axis of rotation will be like this. Magnetic axis will be like this here. The magnetic axis will go like this. Earth axis is this line. Earth is spinning around the axis of this. Magnetic axis will be somewhere like this, going through the Earth. So I have used different colors for you. If you notice carefully, the Earth's north pole, geographic north pole is this. Geographic south pole is this. That is the reason in the first class I wrote 2, SG, NG. NG is geographic north. That is our axis. Geographic south is this. Magnetic axis is this. Okay, let's see this in the atlas. In the atlas world map. World map mein, I'll show you both now. See here, this is the world map. This is geographic north, geographic south. Magnetic axis here. Magnetic north, magnetic south will come here. See here, south magnetic pole. This is south pole. North pole and north magnetic pole. Here. Check it out please. In the atlas world map. In Oxford Atlas, see this atlas, you go to world map again, page number 103. See here, North Pole, South Pole, magnetic north, red color, magnetic south comes here, somewhere here. You see your atlas and mark. Okay. Okay, please check this very interesting topic. Actually, there are two north. Geographic north, magnetic north. Magnetic north is the north identified by our compass, and geographic north is identified by our axis, rotation axis. Magnetic north. It is not showing this. Our compass is showing magnetic north. You should understand this. UPSC definitely it will come. I am telling you. Guaranteed question. All of you got it? North magnetic pole. This is North Pole. Geographic north pole, geographic south pole. 90 north, 90 south. Correct. This is magnetic north, magnetic south comes somewhere here. That corner. In our atlas, this other atlas they have shown. Here. You can check this. Magnetic south also they have given in Orient Black Swan. 82 page number. Orient Black Swan. You got the north magnetic pole here. This one. This comes here. You can check our atlas. It comes here. यहाँ पे आएगा ये नॉर्थ मैग्नेटिक पोल है. Okay, like this. This is not rotation axis. Clear to all? Please bring atlas, because what happens if we see this kind of things, question will come in the exam. Okay. So now the Earth's axis, this geographic axis. Okay. This yellow line is geographic axis. Geographic axis or axis of Earth rotation. Magnetic axis is the axis formed by the magnet. Now the scientists have understood that. Okay, can I continue? Now it's getting tougher. Okay, pay attention. The scientists are saying the magnet inside the earth is moving. Inside the earth is moving. When the magnet inside the earth is moving, don't you think the magnetic axis also will change? That is the reason our compass is now alignment is changing now slowly. This geographic axis is fixed. Geographic axis is fixed. That is not changing. The magnet inside the earth is moving. Inside the earth, the core is moving. Inner core is moving. When the inner core moves, this magnet also will move, because inner core is same as magnet. When the magnet moves, what happens to the magnetic axis? Is moving now like this. So that is what we are discussing now. So there is a shift in the Earth's magnetic axis. That's what everybody is talking about now. So we have never studied this earlier. So magnetic axis shift hone se, a lot of things can happen. This can change means what? Our radio reception here, radio communication will be disrupted here in this region, polar regions mein. Satellite phones won't work. That kind of satellite disruptions are occurring now here in the polar region. Okay, so our remote sensing satellites go like this, remote sensing satellites of the earth, Indian remote sensing satellite, ऐसा जाता है, देखो ऐसा, like this they go, pole to pole. It covers 81 degree north to 81 degree south, ऐसा जाता है satellite. Our satellites signals from polar region when they are here get disrupted. You got it? So this kind of magnetic axis changes will change the magnetic lines, which will disrupt our satellites also. So satellite communication, radio communication on the surface, all are changing now because of this. So the magnet inside the earth is slowly shifting. The magnetic north, which was in Canada, you saw Canada there, North Canada. All of you see that, North Canada. Country is North Canada. It is now shifting towards Siberia, Russia. It is shifting towards Siberia. So that is the information now. The north magnetic axis NM, the north magnetic pole NM, presently in which country? North Canada. Okay, northern Canada mein hai. It is now shifting towards Siberia, Russia. This you write here somewhere. In one of the class, I'll explain this. Too technical. Okay, very technical topic. So please remember, from North Canada, the magnetic north pole is shifting towards Siberia. That means magnet inside the earth is changing. Okay. Can I continue? Okay. Now you might say, sir, how it is going to affect us? Earth magnetic axis shifting. How it is going to affect us? Normally I'll tell you. The simple ones I'll tell you. For very long, the magnetic axis was fixed like this, showing it in Canada here, and here in South magnetic pole was showing towards Antarctica, East Antarctica. Across the world, whenever we build airports, the runway, have you seen runway? The runway is always aligned this axis, magnetic axis, mein align hota hai. Every runway around the world. So the pilot used the magnetic axis and the runway. Correct. When the plane is exactly coming on the runway, the plane also aligns with the magnetic axis. Now if this Earth's core is changing, what is happening now? The magnetic axis also is changing now. Now we have to change our runways also. Till now, all the airports around the world, the runway direction was aligned according to the magnetic axis. Till now. That is the reason you go to Shamshabad airport, Hyderabad mein, it has some runway. The runway direction is something else. Based on that, they'll build the airport. First, they'll build the runway. First, after that only the airport structure will come. Based on this axis. Now it means the axis is changing slowly, means what? So we have to align our airport runways again according to the magnetic axis again. So that has become an infrastructure, extra expenditure for many governments now. Correct? So the airport runway, because when the plane lands or takes off from the runway, the pilots inside the plane also there is a compass. Okay, so that aligns with the magnetic axis. Okay, so this is very important for planes to land successfully, properly, without any disruption in different parts of the world. Any change in the magnetic axis, the planes also have to change the alignment. So that I'll show you. Now that has become a news now. Many things I'm telling you, it's like first time you might have been hearing this. Okay, but UPSC will ask all this. We call it as magnetic heading. I'll call it as magnetic axis. See, helps the pilot quickly identify the runway's orientation for takeoff and landing. Magnetic axis in turn refers to the imagery that connects Earth's magnetic pole. Magnetic pole. So remember this. So this is the article. So the article, like everybody, nowadays people make reels and videos and all on every issue. See why airport runways get renumbered and the impact of Earth's shifting magnetic field. So the impact of Earth's magnetic field happens. Again, then our axis changes, magnetic field changes, and also the runways have to be changed or slight alignment has to change. Okay. So please remember this. Those advanced part, runway part and all, don't write in the answer. Just remember the north magnetic pole axis, magnetic axis is shifting towards from Canada to Siberia. That is what the question will come. The magnetic north pole is shifting from Canada to which country? Towards Russia, Siberia. That is one question. Why it is shifting? Because the Earth's core is shifting inside. Inner core is changing. All this information we didn't know earlier. Now we are realizing all this. Okay. So, see, slight change in the Earth's magnetic field has a far-reaching consequence. Okay. Now, the sun's solar flares. Last class also I had shown you. Quickly we'll see that.